Right. So in numerical methods, our primary agenda is to expand any given function in Taylor series and see how far we can calculate things. Right. So while expanding the function in Taylor series, the first problem that comes is errors. So we have seen about two types of errors. One is truncation error, another is round off error. Right? So when you just neglect the higher order terms in the Taylor series, you will get truncation error, and when you round off the result, you will get round off error. Right? Best example for that is estimation of value of pi. Estimation of value of pi. So it is obtained by tan inverse 1.0 is equal to pi by 4. This is the standard value. So now we try to generate this function as a Taylor series. Tan inverse x. Right? So tan inverse x is given by one by 1 plus x square. So now we have to take Taylor series or binomial expansion for this 1 by 1 plus x square. And the basic functions that we know is 1 by 1 plus x expansion is 1 plus x power minus 1. If you take this binomial expansion for that, it is 1 minus x plus x square minus x cube minus x cube. Okay. And here we have to take square of that. So here we have to get the series for 1 by 1 plus x square. So instead of x, we have to replace it with x square. So what you get is 1 plus x square whole inverse is 1 minus x square plus x power 4 minus x power 6 plus x power 8. It's now integration of this. So integration x square n plus 1 by n plus 1. So you get x by 1, x cube by 3, 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 plus 1 by 9, like that. We'll get so this value will be equal to 5 by 4. So now we compare these two values. Whatever value you obtained from built-in function and the value obtained from this series. So these two things we need to compare. So how to start the program? Program 5, implicit none. Next entry. సో సిరీస్లో నెంబర్ ఆఫ్ టర్మ్స్ ఎన్ని తీసుకోవాలనేది n అనుకుంటున్నాను. కాల్ దట్ యాజ్ n. సో నౌ what do you get here? So pi exact is how to get that? It is 4 times arctan 1.0. So now I'm asking user to enter the number of terms in the series. Series లో ఎన్ని terms కన్సిడర్ చేయాలనేది so whatever text that exists in double quotes will be printed as it is. So the text other than in double quotes will be considered as a variable. The text in double quotes will be considered as just text. So enter the number of terms in the series. I'm reading that. So once you read that, you have to generate this series. So I'm using that loop do we need another variable also. I is equal to 1 comma n to generate these odd terms 1 by 1, 1 by 3, 1 by 5. Actually everything is multiplied by 4. 4 by 1, 4 by 3, 4 by 5, 4 by 7, 4 by 9, like that we have to generate. And at the same time we have to generate alternative plus and minus lines. So these two things we need to generate from that. Right? So initial value of phi approximation is 0. Initial value of pi approximation is 0, and then I'm starting with that. Do I is equal to 1 to n. Pi approximation is equal to should we add so when I is equal to an odd number we should have plus sign. When I is an even number we should get negative sign. So how to get that? Minus 1 power I plus 1. Double star stands for power. So minus 1 power I plus 1 gives you what? When I is equal to 1 you get plus 1. When I is equal to 2, you get minus 1. I is 3. Plus 1 again. So that minus sign we have generated, alternative plus or minus signs. Then we have to generate all odd numbers. When I is equal to 1, it is 1. I is to 3. I becomes 3, you have to generate 5. So what is that? 2i minus 1. 2i minus 1, right? I is equal to 1. 2i minus 1. 1. I is 2. 4 minus 1. 3. I is 3. 6 minus 1, 5. So 4 by 2 star I minus 1. Error for n terms is pi exact minus pi approx. Write all the three. By pi exact star 100 percentage error, relative error, absolute error, percentage error. Pi exact minus pi approximation, pi exact minus pi approximation by pi exact, pi exact minus pi approximation by pi exact multiplied by 100. All the three. So if you want to write them separately instead of this, absolute error is comma pi exact minus pi approx. Like that, you can write all the three in separate lines. Instead of this. If you get that 72 limit, otherwise it's